Okay, thank you very much. So last time we have prepared a video related with introduction part of dairy chemistry course. So especially overview of milk production as well as milk secretion as introduction part of this course. Today the continuation of the previous lecture. Today our topic is focusing on factor affecting the composition of milk. So before directly we proceed to major factor affecting the composition of milk. So let me define milk. Of course, I think we tried to define last time. I think it's good to define milk in different perspective to have a comprehensive information about definition of milk. So milk is defined as undiluted, meaning the milk should not be adulterated with any substance out of the natural component of milk. So the other one is fresh lactal secretion obtained from one or more hazy cow followed by complete milking is definition of milk. So again, the definition of milk consists of excluding colostrum. So when we talk about milk, colostrum should not be a part of milk, especially this colostrum is produced 15 days before the animal giving birth and 5 days after giving birth is not considered as milk. So anyways, when we talk about the definition of milk, so the milk should not be adulterated, it should be wholesome. So again, it should be fresh lactal secretion of one or more healthy cows. So the animal should be healthy, so the milk could be extracted or milked from single cow or more healthy cow. So at the same time it should be fresh. Again, complete milking. Complete milking has its own impact on the composition of milk, especially the first drop of milk contain less amount of fat when compared with the last drop of milk with high percentage of fat. So because of this reason, complete milking is very critical, especially those who are working on research to have representative milk sample. So the other one is colostrum. The nature of this colostrum is different from normal milk. So because of this reason, it is not a part of milk. So the other one is this bulk milk, which is obtained from different sources, may differ widely in composition. I think the milk will be bulk, collected from different part of the place. So the composition is not the same. So the composition of milk is vary depending on many factors. So those factors can be categorized under physiological factor, genetic factor, environmental factor, as well as this pathological factor. So this source of variation can be categorized under these four major influencing factors. So even milk obtained from individual cow, from single cow, may vary from one to another milking session. For example, if it a morning milk and evening milk, you can have not the same milk yield as well as milk composition, especially when the interval is short. So the milk yield is less, but the fat percentage is high. So even there is variation on day-to-day production of milk. So anyways, there are different factors affecting the composition of milk, but all those factors categorized under these four major source of variation factors. So if we look at this gross composition of milk, so generally milk consists of two important components. The first one is water, the second one is this total solid. So when we talk about total solid, it consists of milk fat, milk protein, lactose, as well as minerals. So these are the major components of milk when compared with the rest component of milk. So because of this reason, we stick with all these four important constituents of milk instead of others. So generally milk has two important components. The first one is water, the other one is total solid. So when we talk about milk, we are talking about water because 97% of milk is water. So that's why the principal component of milk is water. So the rest probably 12.8% is that of total solid. So another important keyword is milk solid, not fat. So this one is all component of milk except milk fat, we call it solid not fat, meaning so entirely we are talking about protein, lactose, as well as mineral. So as we indicated before, so the major factor affecting the chemical composition of milk is it could be genetic factor, environmental factor, physiological factor, and pathological factor. So those of course, there are different factors affecting the chemical composition of milk. All those factors can be categorized under these four major factors. For example, if we look at so genetic factor, so the first one is species, breed, and so individual difference. So, for example, species, so cow milk composition is not the same as that of buffalo. Buffalo milk is not the same as that of sheep and goat. Sheep and goat is not the same as that of mare milk and camel milk. So species is the most important source of variation for milk composition. Again, is breed. So breed is also another important source of variation categorized under this genetic factor. For example, if we take temperate breed, so the famous also non-temperate breed like Guernsey and Jersey and Holstein Friesian, especially Jersey breed, contain or known by production of high percentage of fat when compared to Holstein Friesian. But Holstein Friesian is well-known breed in terms of meat production. So I think some of the breeds are specialized on meat production, the others are in terms of milk fat like Jersey, while milk production is higher in case of Holstein Friesian. So the other important issue is so individual difference. So there is also individual difference in Holstein Friesian. Even in Holstein Friesian, so even in single breed, there is also a variation. So that variation we call it so individual difference. Within Holstein Friesian, we can observing uh, a wide variation in terms of milk production as well as milk yield. So the other one is this environmental factor. So of course, so environmental factor consider many issues. So impossible to cover each and every aspect. So as much as we will stick with feed. Water intake is also important factor affect the chemical composition, especially milk yield as well as milk fat. So the other one is making practice. When we talk about making practice, we are talking about milking interval as well as completeness of milking. So so anyways, the milking interval, for example, with a morning milking and evening milking may not have the same amount of milk yield as well as milk composition. So completeness of milking, I try to explain it at very beginning when we define milk, especially the first few drop of milk contain less amount of fat when compared with last drop of milk. So the last drop of milk contain high amount of milk fat. So the other one is a physiological factor. So especially immediately following birth, so the nature of that's the milk we call it. Of course, that one is not milk, so that one is colostrum. So its nature is different from normal milk, especially high in protein, high in fat, but less in lactose. So later on, some of composition of milk are changing. So age is also another important factor. So especially at force parity, after force parity, uh, most of the components of milks are decreasing. So in terms of yield, for example, if we take first lactation and fourth lactation, the difference is 25%. So probably that one is aligned with so the body weight of the animal. So especially heifers at first lactation, probably 80% of achieving 80% of this mature body weight. So because of this reason, the difference in milk yield is also high. So the other one is mastitis. So mastitis is also another uh, effect under this pathological factor. When we talk about pathological factor, we are purely discussing with the health of the animal. So there are different factors affecting so the health of animal. Of course, we will not cover all of those diseases, but we will stick with the mastitis. So that one is also common problem of dairy farm. So the first factor affecting the chemical composition of milk is the genetic factor. So under genetic factor, so there are three important sources of variation. The first one is species, the second one is breed, so the last one is individual difference. So as much as possible, let me see each of them independently and in depth. So when it comes to species, so milk is the most variable biological fluid. So milk is the most variable biological fluid when compared with any other fluid. Here this one is variable biological fluid because determined by many factors. So again, this one is also complex biological fluid. So because milk contain more than 100,000 different molecules in different state of dispersion. Some of them are in immersion, some of them are in suspension, the other one is forming through solution. So milk originated from various milk animals, including cow milk, buffalo, goat, sheep, and camel. So those milk is important for human consumption. So in different countries, milk is produced from different sources of animals. So in case of Ethiopia, so the most source of milk is from cow and that of camel. Anyways, in our world, majority of milk is produced from this cow milk. So the composition of milk vary between species, particularly in relation to percentage of fat and the type of fatty acid present. It's not only a matter of fat. So the fat acid makeup is also varied. So for example, if the fat content in buffalo milk is higher than that of human milk and that of cow's milk, so the fat content of buffalo is a bit higher than that of both human as well as this cow milk. So again, so if you look at conjugated fatty acid, specifically is conjugated linoleic acid, so there is a variation between even goat and that of sheep. So conjugated linoleic acid is a bit higher in case of sheep. In case of sheep, 0.82 gram per 100 gram of milk, while in case of goat which is around 0.48 gram per 100 gram of milk. So there is also a variation even in case of any small ruminant. So if you look at this table, so the composition of milk for different mammals, for example, if you take human milk, contain high amount of lactose and less amount of protein. So in case of cow, when compared with human milk, lactose content is less, fat content is less, the protein content is higher than that of human milk. If you look at mineral content of cow milk is higher than that of human milk, especially the protein. Less amount of protein in cow milk is implication on the growth of babies when compared with the calves of cow. In order to register double birth weight in case of human milk, it requires 5 months. Look, in order to register double birth weight in case of baby, it requires 5 months. But in case of calf, it requires only 3 months. So this difference usually happening due to this protein content of milk. So those animal contain high amount of protein in milk means that so the days required to register double birth weight is shorter than so the animal contain less amount of protein. So if you look at sheep, the fat content is high, so the protein content is a bit higher than that of protein. Lactose content is the same, the mineral content is a bit higher than that of cow milk. So the same is true for some other animals. So in general, from this table we can conclude that so the composition of milk is varied depending on different species of animal. Meaning horse is not the same as that of donkey. For example, if you take lactose content in case of donkey is 6.7, horse is 6.2. There is also a variation. So there is a variation in terms of protein. There is also a variation in terms of fat. So the same is true for that of camel milk and that of goat milk. They are not the same. There is also a variation in case of lactose as well as in case of protein. So in general, species is one important source of variation in terms of chemical composition of milk. So the second source of variation in genetic factor is breed. So milk yield and composition are hereditary characteristics, and they are influenced markedly by breed. So breed is also an important factor that affect the milk. It's not only milk, so the composition of milk is also determined by breed. So as we indicated before, so milk is originated from different dairy cattle breed, has shown difference in milk yield as well as so chemical composition. For example, if we take Guernsey and Jersey breeds, they are contain or known for high fat content than that of Holstein Friesian. Almost these three breeds are temperate breed. So in terms of milk production, Holstein Friesian come first. So in terms of milk fat, the Jersey breed come first. They are next to that of Jersey. Holstein Friesian is the least breed in terms of fat content. So if we look at this indigenous breed like Zebu cows can give more fat percentage even than that of the same breed. So anyways, in general, breed has its own implication. It's not only milk yield, it has also implication on milk composition. So lactose in large content of milks are also affected by breed, although it's to lesser extent when compared with that of milk fat. So milk fat is most variable component of milk when compared with other component of milk. So breed producing less milk yield have higher fat and protein percentage. So because milk yield is so inversely proportional that of milk fat as well as protein percentage. So both fat and protein percentage are, especially fat is inversely proportional that of milk yield. So animal producing high amount of milk yield means that so the percentage of fat is less. Also, this increase fat and protein yield. Breed producing higher volume of milk have higher lactation, fat, and protein yield. So if you look at the whole lactation, so especially those animal producing high amount of milk, so if we calculate the whole lactation, so those animals are producing high amount of fat and protein. So if we look at the percentage per ml of milk, so when the milk yield is higher, so the fat percentage is less. So another important issue is the fat to protein ratio in milk of different breeds differ considerably. For example, if you take, so in case of Holstein Friesian, so the fat protein ratio is 1 to 0.9. So there is also a bit difference in Ayrshire, one ratio to 0.91. So while the difference is high in case of Jersey and Guernsey when compared with Holstein Friesian and Ayrshire. So meaning, so the fat content is a bit higher when compared with protein. So the fat to protein ratio is important with respect to the following perspective. So the first one is it determines the composition of dairy product. For example, if you take there is a standard, the protein as well as the fat content should appear in a certain product. So by the way, the other issue is so the major factor in determining producer milk price. So the milk price is usually determined by the milk fat. So for example, if it because butter is very expensive, cream is very expensive, the same is true for that of protein. So that one is important to make cheese. So when the unit of price between those two components differ significantly, this may affect so the breeding strategies. So the breeding strategy is influenced by so this important factor. So in the milk of single herd, so this may indicate diet deficiency with regard to roughage and energy content. So of course this one is also influenced by both energy feed as well as roughage. So roughage is directly aligned with so milk fat. So later on I will also explain how energy and roughage diet affect this composition of milk. So if you look at I think this table, so the genetic correlation between milking trait. From this table we can conclude that so genetic correlation between milk yield and fat and protein yield are highly positive, right? Milk yield and fat and protein yields are highly positive. For example, if we take, so if you look at so the fat kg is around 0.88 or meaning 88%, while the correlation between milk yield and fat is which is around 20%. If we look at so this table, the genetic correlation between milk trade. For example, if we take, so there is fat, protein in terms of kg, fat and protein in terms of fat, in terms of percentage. So that one in terms of kg, this one in terms of percentage. So let we summarize by this sentence. So the genetic correlation between milk yield and fat and protein yield are highly positive. So that one is more than 88%. So the correlation, there is a correlation between milk yield and fat and protein yield are positively correlated, while the correlation between milk yield and fat and protein percentage is negative. When the milk yield is increasing, both fat and protein percentage is decreasing. So therefore, breeding for more milk would increase the fat and the protein yield, so reducing the fat and the protein percentage. So if we look at breed, so breed has also implication on the composition of milk. For example, if you take a Zebu breed, contain high amount of fat when compared with other temperate breed. So, for example, in the temperate breed, so the variation in terms of fat percentage is high. For example, if you take Jersey breed come first, the next one is Guernsey, so the next one is Ayrshire, so that one is followed by Holstein Friesian. So Holstein Friesian is known in terms of meat production, but in terms of milk fat, so this one is a least breed. So this is also important source of variation. So the same is true for other constituent of milk, more or less. But the most important factor influences the fat percentage. So the other one is so individual difference. So milk of individual cow within a breed varies widely both in terms of milk yield as well as composition. So even the composition and the yield of milk is also influenced by individual difference. Within Holstein Friesian, within Jersey breed, there is also individual difference. So within also local breed like Borana breed or Fogara breed, so the difference is also very high. So the potential fat content of milk from an individual cow is determined by this one genetics. Okay, so that one is so impossible to explain it. So genetic factors also affect both protein, lactose, as well as the fat percentage of milk. So the selection for breeding on the basis of individual performance is effective in improving milk composition and quality of milk. So in order to improve the composition of milk, so selection based on the merits of protein, lactose, and fat is also critical. So therefore, calorie cutting of total milk yield, fat, solid not fat percentage will indicate the most productive cow, and a replacement stock should be bred from this record. So record is very critical to have. So the better promising breed in the future in terms of milk composition, particularly milk fat, protein, as well as lactose. So second